Hey guys, we're going to do the stats review 1 and 2. All right. Now, chapter 1 and 2 review homework. So let's do it. So it says here, which of the following is categorical? So here we go. Make sure that you don't just put A, B, C, or D. Make sure you write something out that looks like you know what you're doing. Okay, so number of dogs you count. Okay. TV channel numbers. Right, so that's that kind of sounds like you could count how many numbers. Shoe size, that you could count, sounds like, right? 5, 6, 7, 8. Number of songs. Number of songs played on a radio station. Okay, that's definitely quantitative. I'm counting up. Number of songs stored on it, so same thing. This one's definitely quantitative. So number of dogs in a house. I'm counting up the dogs. So this one's definitely quantitative. So I've really narrowed it down to B and C. And technically, if I gave this on a test, I would say personally, I would either take B or C because I think you can make either one of these a category. Probably the TV channels because kind of like on a radio, they're not really numerical. So this I would call categorical. And so we're going to go with B. Okay. But I would take either one of those. All right, 2. Which variable is most likely to be skewed right? So what that means is if I ask people some questions, what would it look like? So usually skewed rate data is data having to do with how much money we make or things we buy with our money, just, as a general rule. So let's take a look. Students' grades on a statistics test. Well, you could give a lot of A's, wherever A is, right? 100. Height of males. Okay, we know height is usually like this, and that's the average height, and there's people that are shorter and people that are taller, even amounts. So I don't like either one of these. And I have to clue in on the word most likely to be skewed. Number of goals scored in a soccer game. Ooh, okay, yeah. So if you watch soccer a lot, you're not going to get like 8 scores on a soccer game. So I really like this one. What else? Ages of men says so same thing. You're going to have an average age and then people that are younger than the average or older. So D is no good. Color of a car is, that's categorical. Okay. So number of goals scored in a soccer game. So again, make sure you don't just put C. Make sure you draw a picture or write a sentence or, you literally could write the sentence in this one. TV channels are categorical because you can think of them as categories, okay? Nice. Next question. Question number 3 to 6 refers to this diagram. All right, so question 3 said, which of the variable has skewed left? So when we look at this data, it looks like X2 is skewed left. So again, try to give me a picture, quick sketch. And then write skew left. B. Which of the variables is mound shape and symmetrical? So that looks like 3. So this is mound shape and symmetrical. All right. Number 5, which of the variables is most likely? No, so it doesn't mean that other ones aren't possible, but what was most likely the distribution of hair length? Okay, so it doesn't say boy or girl. So it looks like we're going to have a wide variability, right? So I'm going to guess either 4 or 5 I would probably take. So either one of those is fine. My answer key says 5, but again, I would just make a quick sketch and just say, this is distribution of hair length because it's there is lots of variability. Okay. Which of the following is most representative of the cost of properties on the Monopoly board? Okay, so the distribution of cost is fairly uniform and there's a lot of variability. Okay, so if you don't play Monopoly, they've kind of told us we're looking for a distribution that's fairly uniform. So that means the same all the way across, but like all the way across a lot. Oh, okay, so that's 4. So that's why they reserved number 4 for that one. So 6 would be, it looks pretty much the same all the way across with some variation. It's much more uniform than number 5. Okay, so with a little bit above and a little bit below here, number 4 is more uniform than number 5. And that's why I would pick 4 over 5 for number 6. It also, though, has lots of variability. Nice work. All right. Number 7, which of the following are false statements? So I'm specifically looking for false statements about stem and leaf blots. Okay, so for this, you could kind of make an example of one. You could just Google one off the internet or just make a quick example. All right, so there's a stem and leaf plot. They can be used to display both categorical. It's like, wait a minute, I can't put blue, green, yellow, violet on there. I can only display numerical. So this one has to be false. Okay, so I can't pick B and I can't pick E. Now it says they are useful for both small and large sets of data, and that's going to be false. Think about large sets of data. That's when we start going to a 5-number summary, like a box and whisker, because that could house thousands of pieces of data. I don't want to make thousands, so I'm going to say 2 is false. So I've eliminated A, and I like D. I'm still going to go ahead and read 3. One can easily see the shape. That's and anything unusual. So I love that. That is true. So to write your answer, you're going to put 1 and 2 are false, and 3 is true. And maybe show an example of a stem and leaf. Nice. Okay, number 8, it says consider the bar chart. So it's a bar chart because it's not a histogram. Oh, what happened there? My hand drug across, sorry. It's a bar chart because the bars are separated with gaps. It's not a histogram. So what that means is you can kind of think of these as separate items. Consider the bar chart on average yearly tuition to a 4-year university, which is true. The graph is segmented. Okay, so that's not true. So what does a segmented bar chart look like? Well, let's say this was men and this is female. And let's say this was 60%. That's what a segmented bar chart looks like. And that would leave 40% left all the way to 100 for female. Okay? So that would be segmented. I could also put men and women. And let's say we ask them a question. Do you like walnuts? Okay, so maybe 60% said yes. That means 40% said no. Let's say we asked women and 42% said yes. And that means the remaining percent said no. That's a segmented bar graph. So that's definitely false. Number 2, tuition increased less from 06 to 02. So it increased by, so the delta here looks like 14,000 minus 13.6 maybe. So it went up by 0.4 or $400. It increased less from here to here than it increased from here to there. Well, yeah, obviously. So that's true. starting the vertical axis at 13,000. So notice if they covered this up and started the vertical axis at 13,000, it would mislead it. So that answer would be yes. In fact, it would make these look further apart when in fact these are all relatively similar, and this one's quite a bit more expensive, but these are actually not that far off from one another. So that's going to be true. So I'm going to pick C, 2 and 3. Okay. Now, number 9, which of the following is true about a histogram? So I'm going to make a quick sketch of a histogram, right? Maybe it looks something like this. Histograms tell you your frequency here. And this would maybe be, we did one like this today. Maybe we'd have a range of numbers. Now it says the vertical axis can indicate the frequency or relative frequency, and that's absolutely true. So this could mean maybe this was 3 people, 1, 2, 3, or if I talk to 10 people, I could list this as 0.3, 3 out of 10. So I went from frequency of 3 to relative frequency 0.3, and that's totally okay. So that's going to be true. Which are true? There are particularly useful for large data sets, and we would say, yep. Wait a minute, I said true and I wrote the letter F. True. This is going to be true. So this could be a frequency of 3,000 people, and it still lets us see the data. Okay? So maybe you talk to 1,000 people or 10,000 people, and that's 3,000. So that's not my relative frequency, but notice I can have a large set of number there. One can easily see the shape of the distribution in anything unusual. So I think that that's true, right? If I have an outlier out here, I'll be able to see it, and I can get a general idea of the shapes. So I think all 3 are true, so we're going to pick D. So to get credit on here, you can draw a picture or just kind of make a sentence summarizing that for your notes. 10. Which of the following are true statements? For a given data set, histograms can appear to be different if the interval widths used in the 2 diagrams are different. So I believe that is true because that's happened to me before when I made it. So let's give an example. So if I look at the data up here, and let's say I change this to 3. So let's say that's 3 and that's 2. Maybe that's 6 and that's back down to 2. If I change the width to 10, then that means I'm going to take these 5, 1, 2, 3, 4, 5, make that there. I have 5. And if I'm going to take the interval from 10 to 20, 10 to 20, and I've got 8. Notice my shape, because I changed the interval width, it is giving 2 different histograms that have the same information in them. Now let's check out number 2. For every bar chart, you can construct a pie chart with the same information. Interesting. I would not say that that was true. I'm wondering how to explain that. Maybe I can explain that I might have to do a little digging. All right, let's look at 3. Every symmetrical distribution is unimodal, and that's absolutely not. So let's say your data looked like this. It's symmetrical, right? So this could be the average number of calories for men, and this is men up here, and here's their numbers, and women. And because a typical man would eat more than. And so you might see data that's totally symmetrical, meaning you could fold it on top of itself, but it actually has 2 modes, or the number that is the most. All right, so what do we get for our answer? I found that only 1 is true. Let's take a look at 11. Given the following stem and leaf plot, which of the following is true? Okay, so it says the mean would be a good distribution of a typical value. Interesting. I don't like that because this data looks skewed. If this was a histogram, I could think of this as the height of the histogram. This can be short, 5 high, 7 high, and 10 high. So 5, if you can think of it, turn your head and you think about this as a histogram. That's what it looks like. Definitely, it looks skewed. So skewed data is the median is a better measure of center. So is the distribution positively skewed? It's skewed down. It's not skewed to the right. It's skewed toward negative values, not positive values. It's an interesting wording though, isn't it? But I don't like that. Okay. If 60 is passing, most students didn't pass. So if 60 is passing, it looks like most students got higher than that. So that's false. If 60 is passing, most students did pass. The distribution is mound shaped. This does not look mound shaped. When I think of a mound, it looks like that. So our true must be here. The range is about 50. So let's calculate that, and that would be easy to jot down. So the range is, the highest number is 99. Here it is, 99 and 51. So 99 minus 51 is 48, which is about 50. So that's why I like it. All right, 12. Given the following comparative bar graph chart, which of the following is true? Okay, so now we're going to be able to compare this. This is nice. And so we have men and women. So it says here the percent of women who prefer cats. So I'm just looking here at the percent of women. So that's this one here, right? The percent of women who prefer cats is higher than the corresponding percentage of men. And I like it. I'm going to say that's true. Let's look at the other ones. The number of male dog lovers in the data set is greater. Okay, we don't know how many men we talk to, so we can't find out that information. A higher percentage of women prefer a pet other than a dog. That's not, like, we don't have that. In fact, there's no data of women that prefer other. About 30% of people in the sample prefer cats. We don't know how many people are in the sample. We just know their distributions once they tell us how many. Many are in the sample. Okay. So I could have asked 1,000 men and 10 women. And so that's why anytime they talk about the total population, I don't know. Almost half of the dog lovers are female, okay? Of the dog lovers would be actual people, and I don't know that. So I like A the best. Nice. All right. 13. Given the following pie chart for the data on a car driven for a sample of students, which of the following is true? Ooh, I can't really see this very well. Okay. I'll piece this together here. So it looks like 15 is other, 20 is trucks, 30 is sedan, and 35 is SUV. Okay. Students tend to drive cars in the U.S., sedans. It's interesting how they ask that, because it's like that's only 30% is sedans. And 30 plus 15 is less than 15. So I don't like that. Most teachers don't drive trucks. This had to do with students. More students in the sample drove SUVs than other types. That's interesting. More students in the sample drove SUVs than all other types of vehicles combined. No, not all other types combined. See, if I combine these, then truck and sedan combined is more than that. So yeah, I'm definitely eliminating C. D, a higher percentage of students drive SUVs than any other type, and that's true. It was the number that was the highest of any number by itself. More students drive Jeeps, and we don't have that info. 14, the most appropriate graph to display data collected to show the relationship between the number of TVs and the number of people in a group of randomly selected households is. Okay. Let's think about this for a minute. I've got two quantitative datas, right? So I've got number of TVs and I got number of people. Okay. So let's say if I got a lot of people, like 10 people, I'm probably going to have a lot of televisions. And if I only have one person living alone, they might have not a lot of television. So I'm actually thinking that a scatter plot, a scatter plot would make the most sense here. Nice. Last question in this section. The most appropriate graph to display data on favorite food for students in your stats class is. Oh, okay. So favorite food would be categorical. And so the one that would look the best is this bar chart. That's basically what we've been using, bar charts, to display categorical data. So this categorical data, like this cat, dog, and other, that's probably the most appropriate. Nice work, guys. Check out the next video for chapter 2.